Welcome back, this is episode number 8 of this tutorial series / crash course on ROS2. You can find the series playlist in the description. And let's get started. In the last tutorial, you have created a Python publisher, so now we are going to create the other side of the communication, which is a subscriber. So in our Python code, we will be able to receive data from a topic. And now, before we even start, we need to know what kind of data do we want to receive, what topic do we want to listen to. So I'm going to run the turtle sim, so ROS2 run turtle sim node again. Okay, we have this, and if we do ROS2 topic list, let's see what do we want to receive. So here, command velocity is actually to send data to the turtle sim. The pause is actually published by the turtle sim node. So if I do RQT graph, okay, let's refresh. And if I uncheck those boxes here, dead syncs and leave topics, you can see now, so we have the turtle sim node here, which is subscribing to command velocity, but the turtle sim is also publishing turtle1 pose. So the pose is the current position. So pose is position and orientation of the turtle. We have also other topics, but let's focus on that one. So for now, the turtle sim is publishing to that topic, but there is no subscriber, so the messages are just not used. I can do, for example, ROS2 topic echo with the pause. Let's see what we get. You can see we have, so we receive very fast messages with the x, y, theta position. Okay, so that's the x-axis is going to be this one. The y-axis is going to be that one, and the theta is going to be the orientation. So 0 is looking forward here to the right. And we also have linear velocity and angular velocity. So let's say we want to create a subscriber to get the current x and y position of the turtle in the window here. So we will need to subscribe to, let's come back here, to the turtle1 pose topic. Now we need more info, so let's do ROS2 topic info. So you see for now we have one publisher, and you can see that this is the type, turtle sim message pose. And we can do ROS2 interface show with this. And you can see inside we have float 32, so that's the float number, x, y, theta, and then linear velocity, angular velocity. That's actually what we have found also here. So now we have all the information we need. We have the name of the topic we want to subscribe to, we have the type, and we know what's inside the message. Now we can start to write some code. So, well, let's actually kill that, and let's go to our workspace again, my robot controller and my robot controller, where we have all our Python files. Let's do touch, actually just like that, touch pose subscriber. Okay, let's keep things simple here, and chmod plus x pose subscriber. Great. Now let's go back to source repository and code dot to start Visual Studio Code here. Okay, and we have this new file, post subscriber. Now we can init. So let's init the file and the node. So user bin env python3. We will need, as always, to import rclpy, and because we are going to create a node, from rclpy.node import node. Now let's create a main function. Args is equal to none, so I'm gonna go quite fast here. rclpy dot init with args is equal to args, and rclpy dot shutdown. Okay, and everything will be in between. So we have our main. Let's create a class. So how do we name this class? Well, let's do post subscriber node, which inherits from node, and def init. So that's the constructor. We call super dot init, and we name the node. Also keep it simple, post subscriber. Okay, so now we have the basic code for the node. What we want to do is to create a subscriber to a topic. So how to create a subscriber? So let's create an attribute here in the constructor, self.pose subscriber is equal to self. So it's quite easy. To create a publisher, you do self.create publisher. Here you do create subscription. Self.create subscription. You open close parentheses. And what do you need to give? First, you need to give the message type. So what kind of message do you expect to receive? If we go back to the terminal, in that one, you can see the interface is turtle sim message pose. So let's just include that. Let's do from turtle sim.msg import pose. And we can put pose here. Note that because we use turtle sim, we need to go to package.xml and it's already here. So we already have the dependency, nothing else to do. So great, we have the type. And then, well, guess what? The topic name. What is the topic name? The topic name is that one. Turtle1, so with the slash. Turtle1 pose. Here. Okay, let's actually go back to a new line here, so that is more readable. And then the third parameter here will be a callback. Okay, why a callback? Because actually when you create a subscriber, you're gonna receive the messages and you want to process the messages when you receive them. So you're gonna create a callback. So you're gonna create a function that's gonna act as a callback, and that's gonna be called every time you receive a message on that topic. So let's name this one pose callback with self, and we are also going to receive a message. So let's put msg, and the message is going to be of type pose. So you can use that with Python to make it easier with :pose to tell Python here that you're going to get a message as a pose object. So you can have auto-completion here in the function. All right, and what are we going to do in the callback? So the callback is going to be called when we receive a message. So let's just print the message. Let's do self get logger with info, and let's do str message. So just the string representation of the message, and we will see later how to process it a bit more. But for now, let's just print the message we receive. Okay, and in the create subscription, we have so message, topic name, and then the callback self.pose callback. And then I'm going to add 10 also as a queue size. So if you remember, that's kind of a buffer. So if you can't receive all the messages immediately, for example, if you have a lossy network or if the messages are too big, this is going to create kind of a buffer. So I'm just going to put it to 10 for now and forget about it. That's not really important at the beginning. All right, so quick recap to create a subscriber. So you create an attribute here in your node, and you do self.create subscription. First with the data type, then the topic name, then a callback and a queue size. For the callback, so what I usually do is I call it, so what I'm going to receive, underscore callback. So that it's easy to know that this function is actually a callback. And then in the callback, you have one parameter, which is the message you receive. And with the message, you can do whatever you want. Now, in order to make this work, I will need to create the node here. So node is equal to pose subscriber node and do rclpy.spin node. That's very important because if you don't make the node spin, well, you're just going to create a subscriber, but then that's it. The node is going to be killed and rclpy.shutdown. With the spin, the node is going to be kept alive, and whenever you receive a message on that topic, this callback will be called thanks to the spinning functionality. Okay? So let's save this and let's try it. Let's actually install it. So let's go to setup.py. I'm going to add a comma here, new line, and let's do pose subscriber is equal to my robot controller dot pose subscriber colon main. So pose subscriber is going to be the executable name. Then package name dot file name, which is that one, colon main. Main for the main function. And then inside the node name here is going to be also post subscriber. All right, so let's go back to the terminal, and we will need to go back here to the ROS2 workspace and do call con build, and I'm also going to put symlink install. Okay, so I'm building this new executable, and with symlink install I can modify it and not having to build it again. So let's do source bash rc, make sure that we source the environment, and let's do ROS2 run my robot controller with pause subscriber. Okay, so the node is running, we have actually nothing. Why is that? Because, well, we create a subscriber and we have a callback and we spin the node, that's it. So if we don't receive any message, well, nothing's gonna happen. But the node is still here. Now on this terminal, I'm gonna do ROS2 run turtle sim with turtle sim node. Let's put that here. Okay, we have the turtle here. And you can see now we start to receive messages on the post subscriber. Okay, we will receive a pause with x, y, theta linear velocity and angular velocity. Okay, because now this node is publishing to the topic pause. Let's check with RQT graph. Let's actually refresh. Let's remove dead things and leave topics. So let's actually check the boxes. Now you can see the turtle sim is publishing to the turtle1 pause and the post subscriber is subscribing to this. So it's just like the turtle sim node was sending messages to the post subscriber. So we can communicate between the two nodes. And now in this, so if I kill actually the turtle sim, you can see we stop receiving messages. If I start again, we start receiving messages again. And now in this terminal, let's do ROS2 run my robot controller with draw cycle. Now you can see the turtle is moving, and also here we will receive the pause, and you can see the x, y, and theta are also moving. Why is that? So let's actually restart RQT graph and let's refresh. You can see now we have the draw cycle, which is publishing something to the command velocity, which is then received by the turtle sim, and then the turtle sim is publishing on the post topic, and the post subscriber is subscribing to the post topic. So when the draw cycle is sending some command, the turtle sim is gonna move the turtle and is also gonna update the pause so that the post subscriber is gonna receive new updated data. And let's come back to the code here actually. So we just print for now the string representation of the message, but let's say we want to actually do more stuff and get the fields of the message. So we can do that. For example, let's actually modify the way we print. Let's just print x and y with a nice syntax. So let's put the parentheses and then str with message dot, and we can get access, for example, to message.x. Okay, and then plus, let's put a comma, plus str message.y, then plus, let's finish with a parenthesis. Okay, so you can access each attribute, so each field inside the message. And then, well, I just print this, but you can do whatever you want. Okay, you can update an attribute in the class, you can decide to call different functions depending on what you receive, etc. So now let's save this and let's actually go back here. I'm gonna kill this node. I'm gonna source the bash sc, and I'm gonna do ROS2. So I'm just gonna run the node again. And you can see now we receive not just the complete message, but x and y. So the turtle is still moving. Yes. And so we receive x and y just like that with parentheses. All right, and you have created your first ROS2 subscriber. All right, that's the end of this episode. If you found it useful, you will definitely like my full course on ROS2 for beginners. This course contains more than 10 hours of content and will teach you everything you need to create complete ROS2 applications. You can find the link in the description. Thank you for watching, see you in the course or in the next tutorial of the series.